Hey everybody, so we have the ThunderCam installed and now we need to align it to our bed. This is going to make sure that we have the best precision possible with the machine and Lightburn. Now what you're going to need to do this is a 2.5 Allen key so that we can adjust the collar on the 2-inch head, and we're going to need some form of material that's flat. I prefer to use cardboard just because I have plenty of it. I always get new supplies from Amazon of cardboard, and I can run this test whenever I need to. But we have to make sure that it is flat. We have to calibrate our 2-inch head to the bed, and we're going to do all of that right now. A quick synopsis of how this works is the camera is taking a satellite view of everything that's on the bed. For the smaller machines, everything is captured. For the larger machines, sometimes you can't get past that back plate. So we're using the center of the machine to align our stuff that is spreading out across the bed. That said, it is taking that satellite image looking down and really measuring pixels of this image. So having the height of the bed or the lens calibrated to the focal distance on the bed is paramount. It needs to be done. It has to be perfect and repeatable. And that's why we're going to adjust that collar so that either we use autofocus or we can adjust that lens up to the collar up to the head so it doesn't move. So the distance of the head to the material must stay the same. The Z-table can move. The material to the head has to stay the same because it is measuring distance. And we'll kind of go through that a little bit more, but that is the absolute necessary procedure that has to happen. All right, let's move on over and I'll kind of show you how I set this up. Okay, right off the bat, something I want to note is this collar is what we're going to be adjusting on our 2-inch lens. The camera is not used with the 4-inch lens. It's not used with the rotary tool. It is used with the 2-inch lens and then also on the flat surface. Now we have to calibrate this head so that we can use this collar and we can use autofocus every time we use the camera to maintain positioning or maintain the distance from the camera to the bed. So again, we're going to focus using our acrylic square or our a way that we can measure for the 5-6 millimeters away from the bed of the machine and calibrate this head at its full maximum height. So real quick, I'm going to go up till it stops. Okay, now I know that this bed cannot go any higher, and this is what I'm going to calibrate to. So we make sure we have access to our Allen key so that we can adjust that. I'm going to slide. I'm going to have to go down a little bit. I'm going to slide this in, tighten it down, put my air hose back on, and I'm going to go all the way up again. Okay. So now I have a little bit of distance here, and that's not what we want. We want this head calibrated to the honeycomb at full height, full stop. So now that the bed is all the way up and I even have my protection, Z-limit protection on the screen, now I can go down. Now one of the things that you're going to have to do prior to raising this up all the way is make sure your head is high enough that it doesn't run into the bed. And make sure you're using the 2-inch head because the 4-inch head will go right through the honeycomb if you raise it all the way up. So have my piece of acrylic underneath. I'm going to drop the lens. Okay, so now that is focused to the bed, not to any material, but focused to the bed. Going to raise up that collar to the point where it hits the mount for, or the holder for the lens. And I'm going to tighten that. And the whole purpose of this is because you want to be able to repeat this without having to measure things or always continually use autofocus, because we are moving this head up and down for other purposes. So now that I did that, I can go down, and now if I need to use my camera, I slide this lens tube up to hit the collar and lock it in. I can also autofocus now, menu, enter. Now that I use autofocus, I should be the right distance as well, because this lens is now calibrated to the bed. We're good to go. You know, as long as you're using the sensors, you should never hit the head, and as long as we're up against the collar or using autofocus, we should always be at the same calibration for using the camera. All right, let me get the cardboard on here, and we can run our calibration test. All right, so I put my piece of cardboard on. I want to make sure that, again, I'm up to the collar, or I use autofocus. Sometimes with material like this is too high, and it's going to clip the autofocus sensor and stop it prematurely. So I'm going to just make sure that I am at full height, up against the collar, and at the proper distance. This is crucial to having this maintain accuracy. So always having it up to your stop, your collar, and then making sure that you are in focus. Again, measuring distance, you start changing the distance from the head to the material, you're going to basically mess up your accuracy of the camera. Something that is as flat as possible for this test, because again, it's measuring distance. So if it is bowed, if it is not flat, we're going to be measuring incorrectly and calibrating incorrectly. So as flat as possible and focused in up against our collar, or using autofocus if we're not triggering it by some, we're not falsing it because of something hanging up higher than the material. All right, this is ready to go. We'll move over to Lightburn now and kind of show how to set up this test. All right, so when we're in Lightburn, we're going to go up to Laser Tools and calibrate camera lens. Now, this is very important. We are not, absolutely not going to do the dot calibration. You're not printing out a piece of paper and doing the dot calibration. We are picking our Lightburn camera, and right here where it says use presets, Lightburn already knows our cameras. So depending on the machine you have, pick the correct one. It's going to be an 8 megapixel 85 or the 8 megapixel 120. So we do that. It doesn't matter what we pick here because the preset defines all of those. We go to next, and then we go to align camera. That's all that you have to do. Notice it is finding our camera. You can see the camera view. Now, another thing to note is a lot of laptops do not have a sufficient amount of power to carry this signal back and forth directly out of the computer. So it is highly recommended that you use a powered hub, so one that plugs into your wall and also goes into your computer for your USB or USB-C. A lot of times you could just buy an adapter that will adapt to your laptop, just a little pigtail. A lot of times that's not sufficient enough. We need as much power to run across this 10 to 15 foot cable and power the camera and send all the signal back and forth. So highly recommended if your camera is not working and you've tried all the other options, that maybe it's just not sending enough power. Apple is pretty well known for this, but I use all powered hubs on my machines. All right, so click finish. Now we need to do the alignment. And most of this is taking place on the laser, but we have to set it up. We're going to go to Calibrate Camera. We're going to pick the overhead camera. We do not have a head camera, so pick that one. We're going to select our camera again, Lightburn. Next. And here, depending on the material you're using, just pick the correct settings for the material. So fill speed. Well, I'm doing it on cardboard, so let's do 400. And fill power. I just need to see the design, which is this design over here, this 1 through 4 grid. I just need to see this design, and I'm picking the center points of these circles. So let's do 20% power. And again, this is on my 130 watt machine. Pick the typical speeds and powers you would use for an engraving on the material that you're using. If you're using a piece of wood, then use those settings that you would normally use. Line speed, we're not cutting, we are engraving. So something like 100 millimeters per second, and again, 20% power. We're moving fast enough to make a mark, but we're not trying to get through the material. And with that, a quick note, the material thickness does not matter. We are going to be engraving on it, and we are not using our Z moves. For scale, we're going to maximize the scale to fit to the edges. On the 63, we can't see past about where this 1 and 2 are right now. So I'm going to make sure that the scale is in positions where I can see them. So I'm going to go up to 300. I'm going to hit my frame. And for this test, for me, for a 63 machine, this is fine. If you have full visibility of your laser bed area, max this out. Again, the scale is for a smaller machine, so that's why it's so high, a 300% increase. So for the 23, it's going to be much lower, 35, a little bit higher. But for the larger machines, the 51, 63, as you can see, we're pretty high up in that scale. So whatever you can see with the camera, you're going to want to try to maximize this test across the entire bed. Okay, so I'm going to use this size. This should work well for what I'm going to use it for. I'm going to click Start, and this is going to start the laser, so make sure you have everything in position and ready to go. Another thing that I'd like to point out is that if we move this camera window outside of our tabbed selections in these two side windows, we can expand it so we can see a little bit better. And at this point, I'm going to go over to the laser, and I want to show you this lens will actually rotate, and it's going to move the lens up and down so that we can focus and get a clearer image. So just twist it to the right or the left, and then go back and take a look at the image on the computer, and fine tune it. If you want to print out a letter of something, some sort, to look at down here so you can really fine tune and get a perfect view and perfect focus, then you can do it like that. Okay, so once the test has run, or this pattern has finished engraving and scoring, we are going to hit Next. Okay, so if it doesn't show up and you click on Capture Image, then it should show up over here to the right. Thing to note is looking at the numbers and the circles, if they are not clear, the lens on the camera can twist to bring things into focus. It's just a quick turn to the right or left and continue to hit the Capture Image, and you'll be able to see if it gets clearer or more blurry. Now, once we have this gantry out of the way and our image up of our 1 through 4 pattern, we can click on the next button. And at this point, we're going to zoom in, and you can click down on your mouse and drag this around. This way you can see these crosshairs. And once you can see the crosshairs, we're going to go 1 through 4, double clicking on the center of the crosshairs. So get as close as possible, double click, then we can move over to number 2, double click, and again we're trying to get as close as possible to the center. If you feel like it's not in the center well, you can undo and then redo it. We can zoom out, scroll down to number 3, scroll in to C, and then we'll move over to 4. Double click there, and at this point it will let you know that you are done by having a outlined box of your camera calibration, like so. And then we click next. Now this is something that you're probably going to do often if the camera gets bumped or misaligned or just isn't accurate. This is the test that you're going to do. You have to recreate that pattern though each time you do it. Now if we go to camera control, if this is not part of your options, then we will go up to window and click on the camera control window, and that'll pop it up. It does not have to stay here, you can move it around. That being said, we can move it wherever we want to. I like it in this window. All right, go to camera control. From the drop down, we are going to select our Lightburn camera. At this point, we can see our overhead view and we can update the overlay. Overlay is updated. At this point, we would draw what I like to do, and this is however you would like to test it. I like to draw a quick little square in there, and then I'm going to see how accurate it is. It's going to touch the insides of this circle. Let me go to my cuts and layers. I just want a quick score line, so line. Again, depending on your machine, use the settings that work for you. 100, 15. So my line speed is 100 millimeters per second. My max power is 15. Okay. And absolute coordinates, this is when we're using the camera. This means that every placement of an object should correlate with the placement on the bed. Granted, our camera is focused correctly. So let me send this over. We'll run this test and verify its positioning. Once you run that test, what we're going to do is come back and hit the camera control, update overlay, and what you could do is zoom in. I like to use my arrow keys and move this over a little bit, kind of change its position so that I can see how close I am to being accurate. And it looks like it's a hair off to the left, and you can see that my camera is a little blurry, so I may want to do some fine-tune adjustments of the focus. But I'm going to create a shift here. This is controlling the width of the actual image. So if there's some distortion, we can correct that. I'm going to put it to 0 and 0 because this was for another machine, but I'm going to adjust my shift as well to make sure it is as accurate as possible. And you can tell that we're moving the image, basically aligning the image with our graphic so that Lightburn knows if it's a little off or not. What I want to do now is, after I make those adjustments, I'm going to save those settings. And now I want to touch the outside of this circle. So we're just going to test it again in a different way. Okay, I'm going to send it over. Okay, and let's test it again. Okay, when that's done, update overlay once again, and zoom in, and that is pretty accurate. I'm not going to complain about that whatsoever. If you want to continue to make fine adjustments, you can. I have the logo, the Air Force logo, on the material that I want to engrave it on, or let's see what it's set up as right now. It's going to be a quick score line, and I can send it over, and we can make sure that these graphics are lined up. But this is the basic usage. Now, keep in mind that you know, with optics, you know, kind of like your vision, as you look outward towards the sides, things get a little fuzzy. Well, this is going to be very accurate in the center where we aligned everything, and then as we get out towards the sides, it's going to be less accurate. But if we use, like if we're making a jig and we use the center position as our fixed point, then everything else in the graphic should follow. But let's test this out and make sure that it did come out okay. Okay, so this came out good. Again, I was just doing a quick score, but as you can see, it did come out correctly and where I wanted it. Now, just a quick overview of what we discussed. We need to calibrate that number 2 lens to the bed so that it maintains accuracy. Fine-tuning the lens so that we can see things clearly. Other than that, just follow the recommended steps that we just went through, and you should be good to go with using your camera. I highly recommend not relying on the camera all the time. Using your origins and start positions are just as accurate, in fact, probably more accurate across the bed than any other method. And that pretty much covers everything in your setup, your alignment, and getting it all functional, ready to use. So hopefully that got you on track and has you using your ThunderCam with relative ease. We'll see you on the next video.